Okay, the Earth and its cycles. First thing we want to look at is, some ideas about the Earth. So there's some misconceptions. The Earth does not have unlimited resources. All or most of the water on Earth is not drinkable, and water does not really disappear when it evaporates. It does change phase, we can't see it, so what does disappear really mean? But it's not gone. It doesn't not become water. It just becomes water vapor, which we can't see with the naked eye. Now, things we want to know primarily are that Earth is a closed system. So, by a closed system, we mean that the amount of carbon, the amount of nitrogen, the amount of water on Earth has pretty much remained the same over the last, 100 million years. It moves around, it changes phase, even goes from one form of carbon to another, or one form of nitrogen to another. But pretty much it moves around these four spheres on Earth. And for about the last 100 million years, it's remained the same amount, essentially. Nothing really goes in, nothing comes out. The Earth we're not constantly sending stuff out into space in any quantities, and stuff in quantities really not coming in. So relative to the quantities, very little has left or come in. So there are four reservoirs on Earth we want to talk about. That's the hydrosphere, which is all the water, the biosphere, all living things, plants and animals, the atmosphere, which is, the gases above the Earth that surround the Earth. It's about 78% nitrogen, 21% oxygen, and 1% everything else. And then the ground and the stuff under is called the geosphere. So the lithosphere, the different layers of the Earth's crust and the core and stuff like that. So there's basically two driving forces that drive these cycles. One is the sun. That's an external source. The radiation hits water, causes it to evaporate, things like that. We'll get into it. And also the internal Earth's core, this radioactive molten core, that also heats things up from the inside. So these cause physical and chemical changes of nitrogen and carbon and water constantly. So the carbon cycle, we'll start with the carbon cycle. That's carbon moving through the different reservoirs. And here's a little picture. And so there's four major things we want to look at in this picture. Primarily, we like to start in the atmosphere with carbon dioxide. So if we go to the next page, we'll look at these processes, and these are the main processes we really want to make sure we understand. So we have photosynthesis. That's when carbon dioxide is taken out of the air, and plants, using chlorophyll or another type of chloroplast, will convert it into sugar. Then they can form polymers of that sugar, make cellulose and things like that. The second one is cellular respiration. So as humans, we eat plants and animals that have sugar in them. We can take that sugar or other carbohydrates and we react it with oxygen that we breathe in, and we generate carbon dioxide and some energy. Over time, we all die, plants die, animals will die, and then we convert, we'll decay through some decomposition into fossil fuels. And then through combustion, those fossil fuels as carbohydrates or, hydrocarbons or whatever they happen to be, wood, oil, natural gas, coal, we'll react them with oxygen, given heat, water, and CO2, which then that CO2 will actually go back up into the atmosphere. So we have this carbon moving from sphere to sphere through this cycle. So here's a list of some of the forms in each of the things. In the biosphere, cellulose. In the hydrosphere, carbonate or bicarbonate are found in the oceans. Carbon dioxide is in the atmosphere, and limestone is actually the major form of carbon in the geosphere. Is calcium carbonate, which is limestone. There are other carbonate rocks that exist in the geosphere as well. So the water cycle, first thing I want to know, there about 70% of the Earth's surface is made up of water. 97% of it is in the ocean. So of all the water on Earth, 97% is in the ocean, 2% is in the ice caps, and only about 1% is found in lakes and streams and rivers and groundwater. And so very little bit, about 1%, is actually potable, drinkable by humans. So water is actually a commodity. Here's the cycle. Again, much simpler, I think, than the carbon cycle, but there are processes that we need to be aware of. And so we have evaporation. That's when a liquid becomes a gas. So, evaporation of water can also be in the form of perspiration or transpiration, but we'll say the sun hits the oceans and evaporates some of the water. The water then goes up into the air, will eventually cool down and condensate, reform into clouds. Those clouds can go through processes of snow, raining, or sleet. That's called precipitation, water falling from the sky. that water has two possibilities. It can run off back into the ocean to be recycled again, or it can actually infiltrate into the ground. So go into the groundwater, where it can also um, evaporate back out at some point or be removed by humans. This is the picture of the nitrogen cycle. We're not going to go into it very much. I have several slides. I'm going to zip through them very quickly. But you know, nitrogen is a very makes up 78% of the atmosphere, so it's very abundant in the atmosphere as nitrogen gas. It's triple bonded, so it does not break apart very easily. There are only certain processes that will do it. Those would be like internal combustion, lightning, or certain bacteria and things like that can break it apart. So we really don't see nitrogen that much. We're just familiar with the fact that nitrogen is very important to plants. The Haber process on the bottom of the slide, where they were able to produce ammonia, was very vital to making crops grow more abundantly on other places in the planet where generally the soil was not fit for it. All right, so then what we want to do is talk about a few different things here. Nitrates, phosphates, and mercury. These are three common contaminants we like to talk about. Nitrates are a friend to agriculture, but they're not so friendly to water supplies. They get into the water, usually from runoff from fertilizer. They cause this eutrophication, which is an overabundance of nitrogen in the soil, in the water, which can then cause these huge algae blooms, which can have detrimental effects. They pull nutrients out of the water that kills a lot of sea life. So we definitely don't want to have a lot of nitrate runoff from fertilizers. Phosphates, again, used to be found in detergents, and they banned them because they were getting into the water and they were causing issues with sea life in the water. There was a large quantity that made it into the Great Lakes, which was a major issue. Now it's mostly found as a preservative in foods. And mercury, it's a heavy metal, very bad for pregnant women, can cause problems to the central nervous system. The main cause we have to deal with right now is that it gets into the oceans. Fish breathe it in, we'll say, and there's a buildup of mercury in fish, generally large fish and shellfish. And there was an actor, Jeremy Piven, who actually almost died of mercury poisoning. He loved eating sushi every day, and he ended up having to drop out of a Broadway show because of it. So we want to be aware of all these concerns of mercury, phosphates, and nitrates in the environment. That's it.